The next concept of linear algebra is about the matrices. Matrix is a two-dimensional collection of numbers, and we will represent the matrices as the list of lists, with the inner list having the same size and representing a row of the matrix. If A is a matrix, then A of I on J is the element with the ith row and the jth row. Say for example, I'll show you over here. The file name is matrix.py. And over here I'll mention, say for the matrix as A of I, small I and J. So I represents the row and J represents the column. So in this chapter we will use two matrices with 2 rows and 3 columns, one matrix, and the other matrix with 3 rows and 2 columns. And later we'll define various functions related to the matrices. Starting with the matrix definition, say A equals 1, 2, 3, and later the next matrix value row is 4, 5, 6. After this comes the next matrice to do compute is B. B equals an array value of 1, 2 and the next value as 3, 4, and afterwards the value comes as 5, 6. After this we will compute the matrices as this is the 2 rows and 3 columns matrix, and here it is the 3 column 2 rows matrix. Now given list and list of representation with matrix A and matrix B, we need to get some function to consider its shape. So for considering the shape of the matrices, I'll mention here in the comment that is shape of matrix, which is def shape of A, and here it starts with the value as number underscore rows equals length of A, and after that comes is the columns, associated columns of it, that is num underscore columns with the length, with the specified length as len A of 0. Okay, so this will be the number of elements in the first row. Now we need to return these values, so I'll say return num underscore rows and num underscore columns. Both the values will be returned. Now to call for the shape of A. Shape of A is nothing but specifying the number of rows and columns in the particular matrices. So for that I'll mention over here as print shape of the matrix is A. So we need to print this. So now I'll go to my command prompt, that is the git command prompt, and redirect to the Python folder in the desktop, Python scripts. Now over here I'll just call for the function of the matrix, that is my Python matrix.py. If there is any error to be computed, that if it's not able to get the matrix, it will be printed automatically over here. So for now we are taking here as yes. Now you can see it is the 2 rows and 3 column matrices. Now in the same way, now I'll print for shape of B. So shape of B will print 3, 2. So this is the way the dimensions of the matrix is depicted over here in the function which is used in Python. Now to get the row and get column for the associated matrix, I'll just mention over here as, now we'll create function for getting row and column. So for getting row, the function is def small df starting with get row, and the value will be A, I, where A is the matrices and A is the matrix and I is the index value for the value which you need to fetch from the given row. Now we'll say return A of I, and after that I'll do the next job is to create a function for getting the column. So that is def get column. So once this part is done, it is A, J. And now it comes with the value as return A of I with the index of j. So it will return a value that is A of I with index of j, and then the next will be computed in such a way that is for A of I in A. So computation has been resulted properly when it comes to get column. So let's print value as A of 0, and the next thing I will print over here is for B. So B of capital B of 0. So let's go to our command prompt, and if there is any error it will be depicted over here. It's over here that we need to keep the indentations properly. We can keep it in this way also in the single line. Now just running, we get that for it's the invalid syntax. We just verify the syntax over here. The issue was with the double brackets depicted. Now again we'll run the code. So you can see the value is properly presented. Just clearing the command prompt and just running up the code again. So 3, 2, and this is the dimensions, that is shape of B. A of I, that is A of 0, is this complete value, and this would be my row. And after that I computed for B of 0. So B of 0 is nothing but the value which is inside the particular column, that is 1, 2. So in this way, get row and get column has been done. Now let's create a function to make a matrix, and this matrix will be represented in the diagonal and identity matrix. So in statistical terms or discrete mathematic terms, diagonal matrix, or we can say the identity matrix, is like identity matrix fetches the value 1 with the product of the numbers present in the matrix, and diagonal matrix means diagonally it will have a value 1, other values will be presented as 0. So let's start with the identity matrix. So we'll have df make matrix with the value as num of rows, that is number of rows, and then comes as the columns, number of columns, and later we have the entry to be depicted, that is entry fn. After this, what we'll do, we'll create the return value for the entry fn, and this will be given as return the value as entry underscore fn with two parameters, that is I comma j, and later we'll say save for the for loop, and that for loop will have a value that is for j in range with, and the range is with respect to the columns, so that is number of columns. And after that, the next for loop will be computed outside that given array, that is for I in range of number of rows. So these parameters is mentioned properly. Now after this, let's compute for is diagonal matrix as definition is diagonal, and this is diagonal matrix will have a value that is I comma j, and these values will be represented over here, that is return 1 if I equals j, else return 0. After this, let's create the identity matrix, and this will be represented in the variable identity underscore matrix equals make matrix with the value I need is 5, 5, that is 5 rows and 5 columns, and the next value is diagonal. So this identity matrix needs to be printed, like it's important, like this matrix should be printed. So for that we'll use a function print identity matrix. Now what we'll do, we'll go to the command prompt and run the code again. So here you can see the identity matrix means nothing but like a value which I get from the product of the matrices present in it. In the form of a determinant, I'm getting a value as 1. And it is a diagonal matrix because 0 of 1 is 1 over here. The Next value is over here, and after that it proceeds to the next position as and when. And if you want to calculate for the shape of the matrix, so we can do it over here as print shape of identity matrix. So running the code will give you the shape as 5, 5. So it is 5 rows and 5 column identity base matrix. So this part has been done successfully. Now the next thing which we need to do is about understanding the statistics. So next section is about the module of statistics, where we will be representing the statistical data, or we can say statistical single set of data.